comment section, can you write what is compiler? Can everyone write? Can everyone write what is compiler? Compiler is set of rules, which is nothing but everything is, see this one. This is rule number 1. This is rule number 2. This is rule number 3. This is rule number 4. Grammar is set of rules. These all, every production is a rule. Compiler is nothing but set of rules. Every rule is a, right? Every rule is a production. Set of rules. Rule means production. Every production is nothing but a one rule. These are known as productions. Shakir, these are known as production, which are nothing but rules. Compiler, total compiler contain, in my opinion, 1 crore rules are there. 1 crore rules are there, which is nothing but 1 crore productions. Total compiler contain 1 crore rules, 1 crore productions. Now my request to everyone, after today's class over, I will give in your, right, I will give in your group. I will give in your group. After today's class over, in your group, I will give TOC lecture numbers. You have to complete them. TOC lecture numbers I will give. You have to complete them. Just only 1 lecture or 2 lecture you have to complete. TOC lecture numbers I will give. In your group I will post lecture number and all. You have to complete 1 lecture or 2 lecture. Right? 1 lecture or 2 lecture you have to complete, so that grammar also okay. Now I think, can you conclude? Can you complete it? Can you complete this one? Lexical analyzer input. Complete fast. Lexical analyzer input. I want only input output. I want only input output. Can you say every phase input output? Every phase input output. Every phase input output. Lexical analyzer input output. Lexical analyzer input. High level language statement. Output token string. Next one, syntax analyzer input token string. Output syntax tree or parse tree or derivation tree. Please remember input output. Input output. This is the only introduction. You cannot get everything. This is only introduction. You cannot get everything. In the introduction itself, how will you get everything? Yeah. In introduction itself, how you get everything? Just I am adding 1 by 1. Slowly you will get 1 by 1. Some people are asking, sir, if I want to create a syntax tree, grammar required, na? That is the meaning of compiler. Compiler is grammar. Grammar means rules. Compiler means rules. Rules means grammar. So using the rules, the token string which is coming, can you draw the tree or not? Verify. How to draw the tree? What is grammar? Right? One lecture is there in the TOC. If you study that lecture, you will get the total grammar story. Don't think much. Don't think much. Tomorrow I will give, as soon as today's class over, I will give that lecture number. Before coming to tomorrow's class, you have to read that, you have to come. You have to read that, you have to come. Fine. Is it okay? Can I move to next? If tree possible, no syntax error. Else syntax error. Can you help me now? Tree not possible. Grammar is wrong or program wrong? Tree not possible. Grammar is wrong or program is wrong? Tree not possible. Grammar is wrong or program is wrong? Tree not possible. Grammar is wrong or program is wrong? Program only. Grammar. Grammar wrong means what? Compiler wrong. Who are you to say this? How can you say compiler wrong? When you say grammar, grammar means compiler. Grammar means compiler. So you cannot say compiler wrong. User program only wrong. Using the available rules for your program, I try to draw the tree. Tree not possible. Oh, program is wrong. You cannot say grammar wrong. Grammar is rules. Yeah, right, like that. Can you say from today onwards? Listen, from today onwards, compilation successful. Compilation successful means tree created or not? From today onwards, compilation successful. Tree created or not? From today onwards, compilation successful. Tree created or not? Tree created. Compilation successful means there is no syntax error. Compilation successful means no syntax error. No syntax error means tree created. Compilation successful means no syntax error. No syntax error means tree created. Suppose the syntax error came. Syntax error came. Oh, syntax tree not created. Means in the program something wrong there. Because with the existing rules, with the existing grammar, I am unable to create the tree. If anyone having doubt how to create the tree and all, no need to think that much. After today's class over, I will give one link. Right? In that link, one lecture is there. If you study that, that will also be clear. No need to bother. Compilation successful. Oh, no syntax error. Oh, syntax tree created. Means program correct. With the existing rules, I try to create the tree possible. No syntax error. Means program is perfect. Remember, this syntax tree is the input to the next phase of the compiler. This is the input to next phase of the compiler. Syntax tree is the input to the next phase of the compiler, which is semantic analyzer. Semantic analyzer. What he will do, let me check. Listen, what he will do, what exactly he will do, I will explain. I will explain. Make sure everyone listen. Make sure everyone listen. We'll take input, see the output. Everyone observe, see the output. See the output now. S goes to ID equal to E. Same tree I am taking. E goes to E plus T. T goes to T star F. F goes to integer constant, which is 60. T goes to F. F goes to ID. E goes to T. T goes to F. F goes to ID. This is the ID2. This is ID1. Same grammar, same tree I am taken. I am not done anything. It's the ID3. It is the 60. Now everyone observe. Everyone observe. Everyone observe. No need to think much. Try to get as much as possible. No need to think much. Try to get as much as possible. Can anyone help me? Assignment operator. Assignment operator. What is the left side? ID1. Can you say what is the ID1 type? Assignment operator. Assignment operator left to ID1. What is the ID1 type? It is a token. Using token, can you go and see the table? Using this token ID1, using this token, can you see in the table? Can you see in the table ID1? What is that variable name? What is the type? Using ID1, can you see the table? What is the type? Name is X. Name is X. Type is float. Am I right or not? So using the token, I went to the symbol table. I got to know it is a float. Can you help me now? Assignment operator left is float. You want right also float or not? Assignment operator left is float. You want right also float or not? You will go there. Assignment operator left float there. You will go right also. E goes to E plus T. To do this plus, left required, right required. Go left. E goes to T, T goes to F, F goes to ID. Again it is ID. ID means token number. Can you go in the symbol table? Can you check? This is also a float. Okay, because of it is a float, here also float will come. Same float will come. Here also same float will come. Same thing, whatever is there, it will proceed further. So to do this plus operator, left side float. So right also float required. Remember in the programming language one rule there. If you want to do any operation between two variables, both should be same type. Between Listen, between two variables, if you want to perform any operation, if you want to perform any operation between two variables, if you want to perform any operation, then both should be same type. Same type. Between two variables, if you want to perform any operation, then both should be same type. Can you help me? I want to do plus operation, left already float. Let's go to right. To do this multiplication, left and right. So first left one required, ID3, it is also float. Because if it is a float, automatically is parent also float. Is parent also float. So star operator left float came. Remember, these all types came from symbol table. These all types came from symbol table. Now listen. To do multiplication, left float, right also float required, but right is 60. Which is integer. Remember, whether you like or not, both should be same type. Can anyone help? Type conversion done. Listen, left side float or not? Left side expecting float. So it should also convert into float. So this 60 will be converted into float. See how to convert. See everyone how to convert. I'm explaining. Can everyone observe? This is 60. Convert this one. See this one. Float type conversion. Float 60. Then it became 60.0. You done the typecasting. 60.0. It will goes to here. Then it became float. 60, which is the float. Float into float. Float plus float. Float will be assigned to float. That's it. So what I mean to say is, remember, semantic analyzer purpose is type checking. Someone should be there to take care about types. Until now, I am not taken care. See, in all the pages, nowhere I taken care about types. See, lexical analyzer, only tokens. Lexical analyzer purpose, tokens only. Only tokens. His goal is tokens. Next one, syntax analyzer, only tree. Syntax, he will take care about syntax. Semantic analyzer, type checking. Semantic analyzer, type checking. He will take care about types. Type checking. Now, someone is saying warning will come. Of course, when you listen, everyone, now if you convert the smaller one into bigger one, warning will come. If you convert a bigger one into smaller one, error will come. When you try to convert bigger one into smaller, you will lose data. Then you will get error message. Smaller size to bigger size. So integer is 2 bytes, float 4 bytes. 2 bytes if you store in 4 bytes, right? You don't lose anything. Space will be more, right? Warning will come. This is called implicit typecasting. Exactly. So remember, semantic analyzer purpose is a type checking. Purpose is type checking. See, left side is float. Then I want everything is float only. See, float. It is also float. But it is unfortunately integer. Integer constant. Right? So do typecasting. It became float. So finally float came. Float plus float again. Next one, float into float again. So like that it is happening. Some people are asking, sir, why are you converting? See the rule, between two variables, if you want to perform any operation, then both should be same type. Between two variables, if you want to do any operation, then both will be same type. Purpose of semantic analyzer, type checking. Now it is the correct time to ask you. Listen, It's a correct time to ask you. Everyone observe. Everyone observe. It's a correct time to ask you. It is a correct time to ask you. Semantic analyzer input. It's a correct time to ask you. Semantic analyzer input. Make it fast. Semantic analyzer input. Syntax tree. Output. Output also syntax tree, but a modified syntax tree. See, somewhere little changes are there. See, output also syntax tree. Somewhere some changes are there, little bit, which is also called as modified syntax. Little bit modification. Modified syntax. Little bit modification. Yeah, he will verify semantics correct or not. Can you say out of all these three people who bother about, listen, out of all these three people who bother about types? It is a very important question. It is a very important question. Out of all these people, who will take care about types? Who will bother about type? Out of all these people, who bothered about types? Someone is saying annotated syntax. Afterwards, we'll see. Yeah, people, whatever you are saying, that is also correct. Can you help me? Out of all these three people, who will bother about types? Everyone. Who will bother about types? Out of all these three people, who bothered about types? Semantic or not? That is the reason. Listen, that is the reason. Now see this one. That is the reason. Everyone listen. That is the reason when our declaration came, those types will be stored by semantic analyzer inside. That is the reason when our declaration is came, those types are stored by semantic analyzer, because semantic analyzer only want types. Semantic analyzer only want type. You only want type, so you only will store. Be careful. If anyone asks you why semantic analyzer is storing types inside, you only want it. Whoever want, they only will store. Who is using types? Semantic analyzer. So you only will store. You only will store. See, if I want, I have to store. Semantic analyzer want types. Whenever a declaration, semantic analyzer will come to the picture. Declaration means immediately semantic analyzer function will be called. It will be stored inside symbol table. Until now, few people are having doubt. Why declaration semantic analyzer will store? Why sir? You needed, na? You only will store. Whoever needed, he will store. Who is using type? Semantic. So you only stored it. You only stored it. Is it fine? Is it fine? Is it fine? Whoever want, he only will do. Perfect. Yeah, fine. Now observe. See this. Remember everyone. Because you want types, you only will store it. So only variable type is stored by semantic or entire table. Only variable type is stored by semantic or entire tables. See, whenever a declaration comes, just remember, right? I think hidden, don't think much. If anything is there, I will let you know, right? As of now, whenever a declaration will come, semantic analyzer will come to the picture. So he will store inside. Now listen once. One small story there. Listen. One small story there. Everyone listen. Whenever a declaration there, semantic analyzer will come to the picture. He will store inside a symbol table, because declaration only will say what type who. Declaration only will say what type who. Be careful. Declaration only will say what type who. Right? Be careful. So I'm doing now. I'm doing. So now see what happened. Now see what happened. Let us assume. Everyone observe. Everyone observe. Let us assume. Let us assume declaration not there. Everyone listen. Let us assume declaration not there. Okay, declaration not there. If declaration not there, symbol table empty. If declaration not there, symbol table empty. If declaration not there, symbol table empty. Everyone know. Because of see this one. Because of declaration, symbol table contains some values. Now no declaration. Now see what happened. Because of lack of declaration, semantic analyzer don't store. Now see what happened. Directly this line is came. Directly this line. Let us assume that no declaration. Directly this line is came. Now see the first line. Now see the first line. X is came. Lexical analyzer is asking, hello X, can you introduce? X said that I am an identifier. Lexical analyzer is saying, if at all you are identifier, you should be there in the symbol table. If at all you are identifier, you should be there in the symbol table. Let me check. He verified. He verified, he got to know. Lexical analyzer is verified. He got to know he is not there. Lexical analyzer got to know that, right, this X is not there. Oh, this X is not there. Oh, it is undeclared variable. Declaration not there. But remember, lexical analyzer purpose is only tokens. He know his business. He know his business very well. Lexical analyzer got to know that X is the identifier, then he should be there in the symbol table. He went and he verified inside the symbol table is no more. Then he got to know that lexical analyzer, oh, X is missing. So, oh, X is not declared. That's the reason this problem. So it is an undeclared variable. You want to give error message. But immediately remember, my goal is only tokens. My goal is not other things. My goal is not other things. My goal is only token. Then what the lexical analyzer will do is, because it is not his work, what he will do is, he want tokens. To proceed further, he want token. Then what he will do is, he will store inside the table, he will store X somewhere. Token number is given, first row is stored, ID1 he will give. Because of you don't know type, he will keep gap. He knows that it is an undeclared variable, but it is not his work. Because his goal is only tokens. Token purpose, whatever needed, he will do only that. Other things you don't care. Sometimes in your life also, right? So something happening which is not belongs to you, you will keep quiet. Somewhere, because you are in the society, there are so many good things may happening, maybe bad things are happening, good things, whatever it is. But sometimes you will see, you don't react because it is not your work. So in the similar way, lexical analyzer also got to know that X is not declared. Oh, it is an undeclared variable. You want to inform to error handler, hello error handler, X is undeclared variable. You want to inform. But error handler saying that, are lexical, you do your work. You don't give unnecessary complaints. What is your goal? Tokens. Do tokens, na? Why you care about other work? Other people work, why you bother? So then what the lexical analyzer will do is, because of he want token number, he will store that one somewhere in the table. But type he don't know, he will keep gap. Then he will say token number is ID1. In the similar way, Y came and Y is saying identifier. So again he will go inside the symbol table, is not available, is undeclared variable. You want to give error, he informed to error handler. Error handler said, do your business. Your business is only tokens. So you will control, you will store Y somewhere, type as a gap. So token number is ID2. In the similar way, Z also. In the similar way, Z also. ID3. Now see what happened. Interesting answer. Now see what happened. It is a Z, it is a gap. So because of the first phase of the compiler, some things he will see, but he don't react. Because his goal is only tokens. He can do. But if he do, what other phases will do? Everyone having their work. His goal is only token. If any other thing happening, right, he will just control. You don't do unnecessary work. Now see what happened. Listen. Now see what happened. Everyone observe. Semantic analyzer is going on. Listen, interesting answer. Semantic analyzer is going on. ID1. He need type. Everyone listen. Semantic analyzer is going on. He need type. Type purpose, he will go symbol table first row. Type purpose, he will go symbol table first row. In the symbol table first row, there is a gap. In symbol table first row, there is a gap. He got to know, oh, Oh, what is the answer? Undeclared variable. X is an undeclared variable. Because of gap is there, you got to know undeclared variable. Remember, semantic analyzer will do type checking. Semantic analyzer will do type checking. He will give two kind of error. One error is undeclared variable. One error is undeclared variable. Type checking he will do undeclared variable because something related to type only. You want to know type event there, type not there. Oh, undeclared variable. Now see one more interesting answer. One more interesting answer. Can you see the one more interesting answer? Everyone listen this also. Everyone listen this also. Into, careful. Int x, y, z. Whenever you say int x, y, z, whenever you say declaration int x, y, z, x integer, y integer. See this one, z integer you store. Unfortunately, you written one more line. Float x, y, z. Already x is into. You written float also. Like semantic analyzer first you tried, he stored everywhere. Semantic analyzer try to store this also, but already x is a into. Again you are saying x is a float. You got to know that, oh, same thing you are declaring two times, multiple declaration error. Multiple declaration error. Remember something related to type. He will take care. One error is undeclared variable. One more error is multiple declaration. Multiple declaration error. Is it fine? Undeclared variable, multiple declaration error. Undeclared variable, multiple declaration error. Is it okay? Semantic analyzer, type checking, undeclared variable, multiple declaration error. Syntax analyzer, syntax purpose. Syntax analyzer, syntax purpose. Lexical analyzer, tokens purpose. Remember, everything can be done by everyone, but there is some controlling. You can study UPSC also. You can study NEET also. You can study IIT JEE also. You can study GATE also. Whatever is your work you are doing GATE. Right? You can study. It doesn't mean that you cannot study other. But what is your assigned work? Do that only. What is the assigned work? Do that only. Fine? Is it okay? Let me know if anyone having doubt. Until now, listen. Until now, no problem there means. Until now, no problem there means, right? They got to know that everything is perfect. Until now, no problem there means everything is perfect. Now you will take the actual thing. What is the ID1? Because of everything is fine now. What is the ID1? ID1 is X. What is the ID2? Y. What is the ID3? Z. Right? This became 60.0. It became 60.0. Now see what will happen. Because of everything is fine, they got to know no syntax error. No syntax error, no semantic error also. Something related to types, semantic error. Something related to syntax like semicolon missing, bracket missing. Those are called syntax. No syntax error, no semantic error means program is almost like perfectly fine. No syntax error, no semantic error means program is almost perfectly fine. Now we have to do the conversion because compilation purpose is high level to low level. Now let me concentrate conversion. From now onwards, conversion will happen, right? Now see conversion, intermediate code generator. Listen everyone now, conversion, intermediate code generator. Intermediate code generator. Intermediate code generator. Everyone observe. Intermediate code generator. Careful now. Intermediate code generator. You only say multiplication and addition. Multiplication is highest priority. Can you see this one? Multiplication highest priority. So T1 is equal to Z into 60.0. It should be done first. Multiplication and addition. Multiplication highest priority. So this will be done in one temporary variable. That is the reason it is called intermediate code. Intermediate means temporary code. temporary code, intermediate code or a temporary code. Z into 60.0, which is the T1. Next one, T2, if you observe, Y plus T1. This is the T1. Y plus T1, which is T2. It will be done in one more temporary variable, T2. Lastly, X is equal to T2. This is called intermediate code because you are using some temporary variables. You are using some temporary variable. This is called intermediate code generation. Because you got to know everything is fine, they will take the actual expression. Now they will try to convert because purpose of compilation, high level to low level. So before this, what we done is we are not converted. We are verifying program correct or not. If program correct, I will convert. See, from here onwards, conversion will start. From here onwards, conversion will start. Conversion will start because program perfect. Conversion from high level to low level. Because you got to know program perfect. See, no syntax error, no semantic error, means program perfect. Now concentrate on conversion. First to do multiplication, next to do addition, that will be stored. This is called intermediate code generation. This will be input to code optimization. If possible, minimize. If possible, minimize. Some people are asking, sir, how will you minimize? Very simple. See this one, T1 is equal to Z into 60.0. First to do multiplication. See everyone, first to do multiplication. Okay, I done multiplication. With that multiplication answer, Y plus T1. Add Y plus T1 will goes to T2. That T2 will goes to X. Why don't you store directly X only? If possibility there, do optimization. Why are you storing result into T2? Finally, T2 will be stored in the X. Why are you unnecessarily expanding? Why don't you optimize? If possibility there, optimize. Okay. Lastly, this is going to be target code generation. This is going to be target code generator. Lastly, you want low level language statement. So everyone know low level language statement. Everyone know. See this one. See everyone. Multiplication means mul. Multiplication mul. Lastly, addition, add. One addition operator. Add is there. Lastly, if you want to store in the X, you can store. Maybe store or a move, whatever it may be. It is not important. Just write some rough idea. So one every line you will see one operator. Multiplication R1, R2. Addition, maybe R3, R4, or maybe, right? You can say R3, R1. Lastly, R3 will store maybe here, something like this. Don't worry that much. That roughly I given the answer. Roughly. Isn't that store operation, right? Store operation, R3 will store in X. Direction I am giving. Book to book direction will change. In the anyhow, in the CO, you will see that. Store X comma R3. R3 will store in X. Target code means mapping. So listen everyone, multiplication there. So mul plus is there. So add. Like that they will do mapping. Because of it is not important, so I am not saying right clearly, not required. Simply target code means final target. Assembly language. Yeah, of course. Assembly language. Just map. Oh, first line multiplication operator. Mul. Second place addition there. So add. Now, one small question I want to ask you. Listen everyone, one small question. It is the main road. It is a road. It is a national highway. Everyone listen. It is a national highway. Careful everyone. It is a national highway. Your car is going here. Your car going on the right side. It is a national highway. This is the way how you are going, right? Your car is there on the right side. Let us assume you want to go left side. How will you go? It is a national highway. Your car is going on right side, but actually you want to go left side. Can you say how will you go? You are going right side, but you have to go left side. How will you go? Will you go directly or will you go middle first? You are there on the right side, you want to go to left side. Will you go directly to left side or will you go intermediate? Make it fast, make it fast. You are there on the right side, you want to go left side. Will you go directly to left side or intermediate? Go middle first. So similar way. High level to intermediate. Intermediate to low level. High level to intermediate. Intermediate to low level. This is the low level. If possibility there, see, if possibility there, optimize. If possibility there, optimize. Code optimization. If possibility, sometimes optimization may not be possible. I have a, listen, I have a minimal DFA. I have a minimal DFA. If I do optimization, I may get same. Minimal DFA already I have. If I apply minimization algorithm, I will get the same thing again. I cannot give guarantee every time optimization possible. Code optimization may be possible, may not. If possible, optimize. If possible, optimize. If not possible, keep as it is. Fine. Some people are asking, why are you going high level to? If you want high level to low level, go high level to low level directly. Na? Don't do anything in life directly. Don't do anything in life directly. You want to go from high level to low level. Go high level to middle first. Middle to low level. That is the reason if you want, you can verify. After summer, listen, after summer, directly, winter will not come. After summer, right, I also identified, after summer, directly winter will not come. After summer, in between, raining will come. Raining season will come, then winter will come. Summer followed by raining season followed by winter. Suddenly summer become winter. It is not possible. It is not good for health also. Humans cannot digest it. So high level to middle to low level. And remember first three people. First three people successful means lexical successful. Syntax also successful. Semantic also successful. These three are over means program don't have any fault. This is checking purpose. These are checking purpose. This is for conversion. Intermediate code optimization, target code. These are for conversion. Because I want to convert from high level to low level. This is for conversion. This is for checking. First verify program correct or not. If program is correct, then convert. Program not convert. Program is not correct. Then give the error so that user can change it. If the program is not correct, then give error so that right programmer can verify, can change the code so that until everything is correct. Remember, valid program only convert. Don't convert everyone. Valid program only convert. Valid program only convert. This is the entire story. I hope you got. Initially, you have many doubts. Now you may not have any doubts.